Okay, here is a probability problem. This is really common in probability to have a deck of cards problem. Okay, so because that's really where probability all started, was people trying to win more money in gambling. Suppose that two cards are randomly selected from a standard 52 card deck, and you ask, what is the probability that the first card is a queen and a second card and the second card is queen if the sampling is done without replacement? That just basically, you got to know some things about cards, right? There's 52 cards in a deck, and that there's 4 queens in each deck. And so we're going to, for the first one, for A, we're going to want the probability that the first is a queen times the probability that the second is a queen. Let's say I want the straight up and down bar. Where is that on my? Actually, I don't think I have that. I'm just going to put this little, it's not really a fraction, but it should be straight up and down. But the probability the second is a queen, given that the first card you drew was a queen. Okay, and we're going to kind of do this twice. One in which the when you draw the first queen, it gets replaced back into the deck. That's the second. You see these keywords without replacement and with replacement. That's the second situation when you put the queen back in the deck and then you draw again and see if you get a second queen. So the probability that you get a queen on the first one is kind of the same in both cases for both A and B. It's really just there's 4 queens in a deck, right? And there's 52 cards. So you have a 4 out of 52 chance of getting picking a queen on your first card. Now, so let's do, this is part A here, and this will be part B. So like I said, those probabilities are the same, okay? But without replacement, like if you don't put the queen back in the deck, then when you go to try to pick your second queen, there's only 3, right? There's only 3 queens left to pick, and there's only 51 total cards because that original queen has been removed. Okay. Now, if you replace the queen, the odds actually stay the same, right? If the queen gets put back in the deck, there's really 4 out of there's 4 queens, and there's still 52 cards. So you just multiply those 2 probabilities times each other. Okay. And then I think we're round to 3 decimal places. So I'm just going to use the Google calculator here. Let me do it over here. It's equal to 4 divided by 52 times 3 divided by 51. Okay, I can see that's to 3 decimal places. That's 0.005. Okay. Now, which is, you got a 0.5% chance of getting that. Now, for the second one, remember we're just doing 4 over 52 times 4 over 52. And here we get a little bit higher probability, which makes sense, right? You've got an extra chance to get that queen. So that's 0.006 for the second one. Okay. And the whole key is whether that queen goes back into the deck the second time you pick or whether she stays out. Okay. So I hope that helps on this question, which was right here.